All right, here we are, SAT for week 10. And we have, for our question, f of x is equal to quantity x plus 6 times x plus 5 times x minus 4. This is essentially a cubic polynomial. If you multiplied all those x's together, it would be x to the third. The function f is given, which of the table of values represents y is equal to f of x minus 3. Okay, and then we have our answer choices, which are just a bunch of table of values. How did we do on this one? Well, you can see a majority of us, 66.9% of us chose answer choice B, which is in fact the correct answer. Now, our second and third place with 21.1, blue, answer choice blue, no, we'll get to the bottom, like why is answer choice A not the right one, or C, which was in second place. We thought that this one was a medium to easy style question. So let's take a look at its solution here, shall we? Okay, so like I said, if you were to expand this thing out, which you totally should not do, if you did, you would have an x to the third, if we care about that. All right, whoa, where are you going? All right, this whole thing, this y is equal to f of x minus 3. In terms of transformations, this is a function transformation. This translates everything down by 3 units. Translates down 3 units. So it takes this whole entire graph, whatever the heck this thing looks like, and goes down 1, 2, 1, 2, 3, right? That's what it does. All right, and you can notice that in each one of these table of values, we're just sticking in the same exact numbers. So we don't have to worry about the x's so much as in different x values for different tables. We're sticking in a -6, we're sticking in a -5, we're sticking in a 4. So one of the things that you could do is just rewrite your equation. We're just taking the original one, subtracting 3 off of it. So f of x is equal to, then we have all these parentheses, x plus 6, x plus 5, x minus 4, and then we are subtracting 3. Like I said, do not expand this thing out. It's a waste of time. Why is it a waste of time? Well, watch what's going to happen if you just stick in a -6. If we stick in a -6 here, this is going to go to 0, and it doesn't matter what these two other parentheses are, and then we're going to be left with -3. Again, what's happening here is this. I go y of -6 is equal to, if I plug this in, like this is, again, it's kind of a waste of time for me to actually write all this out, because I could do this in my head and just look at it and see what's happening. -6 minus 4, and then minus 3. This guy is 0. Who cares what either of these two are, because we're multiplying it by 0. It goes away, poof, and then we're left with a -3. And who has -3? Well, there's two of these things that have -3. That's the answer choice B and C, okay, which eliminates A and D right off the bat. All right, let's see what happens if we choose to put in a -5. Well, okay, just like the -6, one of these things is going to go to 0, and that's this guy. Essentially, these things, the ones that they gave us, these are the x-intercepts, are the zeros of the original function, right? Which is why all of these things are going to go to 0 whenever they stick in these x values here. So now it's the middle one that goes to 0. These two, who cares what they are? We're left with 0 minus 3, which is another -3, which is only answer choice B. You don't even have to look at the other one. It has to be answer choice B because it's the only one that has a -5 comma -3. All right, you can, of course, test it out if you want. You just want to really make sure. If you stick in a 4, this time it's the last factor that's going to go to 0. Who cares what the other two are? And then you're left with -3. Okay, so let's get to the bottom of what each one of the other tables actually represents. So let's look at this one first of all. So notice what happens here. This is a -6, and then I do something to get -9. -5, I do something to get -8. 4, I subtract 3 to get 1. -5, I subtract 3. -6, I subtract 3. This is essentially y is equal to x minus 3. You took 3 away from each of the x values instead of the f of x values from the original function. Okay, so that's a bad move right there. Boop. All right, and then let's look at answer choice C, which looked like it could have been a winner until it wasn't. So let's see what is happening with answer choice C. So negative 6, that's I could get that by a plus 3. And this one, a plus 3 and a 4 plus 3. Yeah, so this is just almost the same thing as answer choice A, but it's y is equal to x plus 3. Also, bad move. Again, well, first of all, it's a minus 3 here, not a plus 3. And then we're not doing it to the x, we're doing it to the f of x. And then what's up with the last one? Okay, so I'm looking at the last one, and it's almost identical to our answer choice B, but it has plus signs here. And the plus signs just mean that it must have been adding 3 to the f of x. So this one is y is equal to f of x plus 3. Also, sad face. Okay, could you have done this on Desmos? Yeah. However, I don't think it actually speeds it up in this case because the numbers that they gave us, the x values they gave us, were the zeros of this function. They cancel each other out. We're just left with negative 3 for each one of those numbers. But I will show you what it looks like on Desmos, because why not? Boop. All right. I do want to type this in as f of x, so I can call upon it in slot number 2 on Desmos. So f of x is equal to parentheses x plus 6, arrow out of it, and then parentheses x plus 5, I think, and then x minus 4. Right, so there's that equation, and here's what I was talking about. If I highlight these little points for you, those are the x-intercepts. Those are the zeros of the function. They're called zeros because it's where your f of x or your y value is equal to 0. Right? And those are the exact same x values that they had in the table. Now, what we're doing here in our equation is we're taking f of x and we're essentially translating it down 3 units. Okay, so this is equal to need my f of x in here, and then minus 3. So remember, when we stuck in a negative 6 here, its y value is 0. And so now what we're doing is we're translating that y value down 3, so it's going to be at negative 3. It's actually a little easier to see if I put this as a y is equal to negative 3 as like a little horizontal line. And now watch this. I'm going to hide this red graph. Just look at the new blue graph, and let me highlight each one of these points. And then you can see the answers right there. Negative 6, negative 3, negative 5, negative 3, 4, negative 3, which is essentially our table of values from answer choice B.